Alright, the previous examples we have worked on are all radial loading. That makes life very easy because with only radial loading, your FR is equal to your PR, right? Your factory load. So what happens if your factory loading now has an additional axle loading that complicate your calculation? So now we are looking into this calculation. Can you go to your appendix page A3-2? Okay, when you're at this page, on the top right hand column, there will be tables. We will use this table when there is an extra loading. We need to determine the intensity of that loading on that particular bearing to determine the X and Y. And of course, to determine which the value of X and Y and substitute into this equation, PI is equal to X FR plus Y FA. FR is your radial load, FA is your axle load. And that will give you your equivalent bearing loading dynamic, your factory loading. All right. So before I move on, let me pose a question. Do you think roller bearing will have this table? What do you think? Okay, when after the video, maybe you want to flip to the roller bearing page and see whether does it have this table. And if it does not, why? Right. Dynamic equivalent bearing load PR. All right. In this case, this PR won't be a direct reading of PI is equal to FR because you have an additional FA XL loading. So to calculate your PR, this formula will be given XFR plus YFA. So you need to determine your X and Y through these given columns and steps to follow. So the value of X and Y will depend on the ratio of FA over COR. Alright, so FA is axle load. What is COR? I will explain to you what is COR in later part and how to obtain this value COR. So these are the steps. We have to use FA over FR. That's the ratio. Your axle load divided by your radial load. Then you compare the E, okay, to it. So if it's bigger or smaller, then that will determine your X and Y. So if it's the first column where your FA over FR is smaller than E, then your X and Y is direct, 1 is 0. So that means your axle load Y is 0. So actually this axle load is very insignificant. But if your FA over FY is greater than E value, then in this case, your X is 0.56, your Y will be determined depends on your ratio of FA over COR. And you need to interpolate to get the correct Y value. Okay, the example, when we come to the example, we will talk about this interpolation. So let's move on. So example 2, use manufacturer catalog. So it's asking you to use nomograph. Right? What is the life of a deep groove ball bearing 6208 arm? So this question gives you a direct number of bearing to use, 6208, under a radial load of 3200 Newton and an axial load of 1650 Newton at 650 RPM of the inner ring. So from this ball bearing, I know that it's rotating at 650 RPM. The shaft inner ring is rotating. The FI is 3002, the FA is 1650. Just a quick one. What is the ball diameter for this case? Do you know how to find the ball diameter? Or what is the shaft diameter if I give you the bearing 6208? Very simple. What you need to do is 08 times 540, so it's 40 mm. Alright, so you just go to 40 mm. Okay, so now I need to determine my PR in order to calculate my life. So I mentioned earlier, you need to find your PR using the chart here, which is appendix A3-2. So the first column state that you need to have FA over C of R. I know my FA is 1650 Newton, but I do not know my C of R. So where do I find or get this C of R? Very simple. Question tells you that I need 6208. I'm using 6208 bearing. So going to that, can you turn to that page? Ball bearing 40 diameter. I'm interested in that column. I go to 6208 bearing number. I look for 628. And once I find the 628, I move to the column. You can see there's two basic load rating and dynamic and static. So this CR, this COR. So the COR given for that will be 16,200. Okay, so this is how you find your COR. All right, so this is catalog COR. So I have all the variables. What can I do now? The next slides will talk about it. All right, so over here, this is the diagram, same diagram. FA 1650, FR 3200, 650 RPM. So I mentioned, refer to the catalog. 6208 is the bearing given to be used. So my COR is 16,200. All right, 16,200. So I punch in this variable FA over COR 1650 divided by 16,200. It will give me a ratio of 0.102. So if you look at the table here at the appendix, okay, 0.102. So it fall in between 0.1 and 0.15, right? Okay, and it give me a E of 0.29 and 0.32. Okay, so what is the value of E? Very simple. Before that, we need to compare the FA over FR to E. So I punch in the number FA over FR 1650 over 320, 3,200. So it give me a ratio of 0.5. So whether you look at 0.5 is greater than both of them. So if my FA over FR is greater, so my column for X and Y will be on the extreme right. Agree? Yeah. So I say again, say over here, FA over C of R is 0.102. Okay, so now I know my E range is 0.29 to 0.32. Okay, never mind. Then I move to the right, I look at these two. So it's quite sequential. I need to find my FA over FR. So I punch in my number FA over FR, I get 0.52. 0.52, you compare over to these two numbers is still greater than any two of these two. So it tells me that I will have to follow this, which is 0.52 is greater than 0.32 or 0.29. So this is the column I'm very interested, which I highlighted in a square red box. And what I need to do is I know my X is 0.56 now. So I have my X, I have my FR, I have my FA, but I don't know my Y. My Y fall between 1.48 to 1.35. That means 1.35 to 1.48. So you interpolate. Okay, so my value is 0.102. So you use this interpolation, you should get your Y. Okay, so you use interpolate to get your Y. So what happens if your E value is directly exactly the value? That means you FA over COR, you get 0.10. So be it, life is good. If that's a question, that's a situation, what you need to do is follow the same steps and you find that it's still the same result, then direct reading with 0.56 and my Y 1.48. If your FA over C of R is exact reading 0.10. Okay, I say again, if your FA over C of R is 0.40, and after you do your calculation, you you calculated that FA over FR is greater than E, then based on this 40 ratio, 0.40, sorry, 0.40 ratio, my X is 0.56, and I will choose 1.05. Okay, so it depends on this FA over COR. But if you divide your FA over COR and it doesn't give you anywhere exact and it give you a value in between, then you have to interpolate to choose the Y, unless this is the column that you choose, you fall into. Okay, FA is smaller than FA over FI is smaller than E, then in that case your Y is 0, so you don't need to interpolate. All right, please remember that. All right, continue from the previous slide. So I know that FA over FR, my ratio 0.52 is greater than E, so my X will be on the right column will be 0.56, and my Y after interpolate will be 1.48. Quite close, huh? So therefore, I will know my PR. I substitute in the variables. My PR after I calculated should be 4234. Okay. Then, so the questions asking for the bearing life, which is FH. All right. So having all these, I am able to determine my PR. I want to find my FH. So I know my FA, FR, and I know RPM. So I go to the normal graph. Go to the ball bearing column, which is the ball bearing. On the left hand side, that's my speed, RPM. So I go to 650 RPM, it should give me 0.37 Fn. Okay, my Fn value should be 0.37. Read from the graph. Okay, 0.37. So given dynamic load rating of the bearing CI is 22400, and because the bearing number is given 6208. Okay, so from 6208 you can get a catalog. This is the catalog CR, so 22400. So so my FH is equal to Fn times R over PR. So after I calculate, punch in the variables, my FH is 1.96. So I go to my normal graph again, look at the bell bearing side, and beside the RPM there's the life, and I go to look for FH because I calculated my FH is 1.96. So I look for 1.9 to 2. And if you calculate 1.9, this is 1.95. Okay, this is 2. So half of it, this is 1.95. So there's one more here. So 1.96 is somewhere here. So you go to the next to the left hand side, that's where 3,000 and 4,000 hours. So 3,000 and 4,000 hours, you divide by half. If you look carefully, this half is 3,005. All right, 3,001, 3,002, 3,003, 3,004, 3,005, 3,006, 3,007. And it's not exactly 3,007 because the 3,007 is slightly below 1.95. But then again, 3,007, the next division is 3,008. So it falls in between 3,007 and 3,008. So the approximate value is 3,750 hours. I mean, this bearing under that condition of FA 1650 Newton, FR 3,200 Newton, factory loading, and with the catalog CR used, at 3,750 hours, the bearing will start to fail. So at 3,750 hours continuous usage, I should change the ball bearing. This is what the catalog, or this is what the calculation is about. That means if you are the supplier or you are the factory owner, you will arrange to replace the ball bearing of your systems when you reach 3,750 hours usage. Of course, you can use the formula to calculate your R10H for the 6208 bearing. When will it fail? All right, so you can calculate using the formula and compare the value you use for the normal graph you obtain. So you realize that 3,750 hours, if you obtain, should be somewhere around that value. But then again, the accuracy of that will be equation will have better accuracy compared to normal graph. Okay, so we can do that and compare with the normal graph reading bearing life. in hours. All right, so this and the introduction of Excel loading. There one more videos that talk about more examples for Excel load and radial load calculations. Then we have a summarized video and you can start your tutorial questions.